Hey guys, Fred here, AF Math and Engineering. This video is going to be all about trigonometric identities. Alright, this is probably one of the major kind of topics that we're going to go through at the first part of Calc 1 in university. And essentially all this part of the course is just manipulating the different trigonometric signs using these rules, okay? Using rules. And these rules have been proven, and you know, if you can remember the proofs, that's good, but you can memorize some of them too. And yeah, that's pretty much it. So what I'm going to go ahead and do is I'm going to put a link below in the description of this video, and that is going to have a list of all of the identities, the trig identities that we're going to need. As I do the question, I'll write out which one I'm using, but I'm not going to write them all out because there's a ton of them. And as well, your calculus textbook, if you have one, should also have the identities in the appendix section. So I'm going to go ahead and I'm going to solve this question. We're going to go through a few of the tricks and the things to look at. And I'm just going to make, for every identity that I write down, I'm going to just highlight it in pink, and it's going to be separate from the question, okay? So don't get confused by that. All right, so let's go ahead and get started. So for the first question, we're asked to prove the identity cotangent squared theta plus secant squared theta is equal to tan squared theta plus cosecant squared theta. Okay, so in these kind of questions, what you're going to have to do is you're going to have to work on one side of the equation, okay? And you're going to have to take a look at which side you want to work with, which side you're more comfortable with, or which side maybe looks a little more easy to deal with. So in this case, we're going to work with the left side of the equation. So we're going to work with cotangent squared theta plus secant squared theta. Okay, so we're going to take that and we're going to work that, and we're going to try and turn that into tan squared theta plus cosecant squared theta using our identity rules. So let's start by writing out the left side, cotangent squared theta plus secant squared theta. And honestly, before I start, a lot of these proofs are actually really tricky and hard, and the only way that you're going to learn these kind of proofs is by doing a bunch of them and seeing what kind of manipulations are done to the identities, okay? So there's a lot of little tricks, and you have to separate fractions, and if you are just planning on just figuring it out by yourself on the midterm, that's not going to work. You have to do a lot of these, so do all of the questions in the back of the book, okay? But this is, hopefully we can just go over a few tricks so we can speed up that process for you. Okay, so let's take a look. Well, back to the question. Cotangent squared theta plus secant squared theta. So, well, what can we start here? Right away, I know that cotangent is equal to cosine over sine. So let's go ahead and let's start with that, and we'll see if that gets us somewhere, okay? So cotangent squared theta is equal to cosine squared theta over sine squared theta plus secant squared theta. Okay, and I also know from the identities page, and keep that open on a separate window while you're watching this so you know what I'm talking about, okay? So secant squared theta, we know that that's 1 over cosine squared theta. So let's go ahead and write that out. So we have cosine squared theta over sine squared theta plus 1 over cosine squared theta. Okay, so I guess we're getting somewhere right now. What can we do here to manipulate this and maybe make it a little more simple and break it down a bit? So what I'm thinking of doing here is maybe we can combine these two and create a common denominator between these two fractions to bring it into one fraction and see if that helps. Okay, so that's maybe a common theme that you'll see. We have two different terms here of different identities, and try and multiply the denominators by each other and make sure that or try and get it into one fraction so that maybe we can work with it a bit better, okay? So let's multiply the top and bottom here by cosine squared theta and the top and bottom here by sine squared theta. Okay, so we're going to be left with cosine squared theta times cosine squared theta, okay? And let's multiply top and bottom here by sine squared theta. So 1 times sine squared theta is just going to be sine squared theta. And that whole thing is going to be divided by sine squared theta cos squared theta. Okay, so I guess we're getting somewhere here, aren't we? We've broken this down into a single fraction, all right? And it looks bigger now than it did before, but don't be scared by that, because this actually does look like it's coming together for us. So the one identity that I want you to really remember, okay, and I'm just going to write this below: sine squared theta plus cos squared theta equals 1. That's an identity, okay? So that is separate from the question, but this is one that you really have to remember. That's kind of the basis for all of these trigonometric identities. And what you can do is you can move cosine squared theta over to the other side, sine squared theta to the other side, and solve for one of them. You can divide the whole thing by sine squared or by cos squared, and you will actually be able to prove all the other identities from this one identity. We're just going to use this one now, and we're going to substitute for cosine on the top, and we're going to try and get the whole numerator in terms of sine. Because if we make the whole numerator in terms of sine, I think that's probably going to make it easier for us to solve. So with that being said, let's go back up here, all right, and let's continue from this step here. And let's sub in 1 minus sine squared. So let's solve in this identity for cos squared theta and plug that in here. So we have, okay, 1 minus sine squared theta, plugging it in for cos squared theta. And let's do that for both of them, okay? 1 minus sine squared theta. 1 minus sine squared theta, all right, plus sine squared theta, and that is all going to be over sine squared theta cos squared theta. All right, perfect. So now we're getting somewhere, okay? And well, what can we do here? We can, I would probably just simplify these brackets here. So we have 1, okay, and that's going to be minus 2 sine squared theta, okay, plus sine to the 4th power theta, plus sine squared theta, right? So let's go ahead and simplify that out. It's 2 sine squared theta, right? So we're just go ahead and we're multiplying these two brackets by each other, and we are left with sine 4th theta plus sine 2 theta over sine squared theta cos squared theta. Perfect. And well, as you can see here, we have two like terms. Okay, so we can break that down into 1 minus sine squared theta plus sine to the 4th power of theta over sine squared theta cos squared theta. Okay, so now we're getting to something that we can really work with here. And as you can see here, all right, we have another identity. So if we solve for cos squared theta here, we can substitute this whole term for cos squared theta. So let's go ahead and do that. So cos squared theta plus sine to the 4th theta, sine squared theta cos squared theta. Okay, and well, what can we do next? What we can do is we can, so if we're taking a look at this fraction, we're taking a look at what can we do here, okay, to break it up into two terms, okay, because we're looking at what we need to solve for up here, okay, and we need to solve for two separate terms here, and we're still left with one fraction, okay, so at this point we're nearing the end of the proof, and we need to split it up into two separate terms, or one plus the other. So let's go ahead and separate this into two different fractions, okay, and as you'll see, if you can see by now, what's going to happen is we're going to have some cancellations, okay, so let's bring this down here. So we have cos squared theta over sine squared theta cos squared theta plus sine to the 4th theta over sine squared theta cos squared theta, okay? And well, what's going to happen here is we have cancellation of cos sine squared theta, and the sine squared theta is going to cancel with the sine to the 4th, and we should be left with 1 over sine squared theta plus sine squared theta over cos squared theta. All right, and well, if we just do the very simple simplification of these, we know that 1 over sine squared theta is equal to cosecant squared theta. Okay, this is cosecant squared theta. And we know that sine over cos is tan, right? So we have tan squared theta. All right, and that's the answer. So that was, you know, as you can see, these are actually very, very tricky, and no, you know, amount of smarts is going to make up for just doing a lot of the practice problems in the back of the book. Okay, so let's go ahead and we'll move to the second question. It's a little quicker than that, and then we'll be done with trigonometric identities. Okay, so in this one, we're going to select which side we want to work with. Tan y, sine y, it's a product of two functions. That looks a little bit trickier to work with. So I'm going to work with the ones on the left, so the difference between secant and cos. That looks a little bit easier to manipulate. So let's try that first. So we have secant y minus cos y, okay? So, well, how can we rewrite this? That's a good question. Let's try and immediately just rewrite secant as 1 over cos. Let's start with that. And let's try and do exactly what we did in the first question and bring it into one fraction, okay? So we're going to multiply the top and the bottom here by cosine y in order to make a common denominator, okay? So we are going to be left with top and bottom, so it's going to be cosine squared y over cosine y. Okay, so we're going to have cosine squared y over cosine y. And, well, do we see any kind of, I guess, familiar pattern from the first question? We do. Okay, we see that we have this common identity that's always going to be showing up, and it's sine squared theta plus cosine squared theta equals 1. So let's go ahead and if we isolate for 1 minus cosine squared theta, if we move this to the other side, that's going to be equal to sine theta, so we can plug that in for the top here. So let's go ahead and just plug that in. Sine squared theta over So if we go ahead and plug that in, we'll have sine squared y over cosine y. That's equal to, all right? And, well, what can we do here to try and make it, or turn it into this function, okay? So at this point in the question, you want to take a look at what you're trying to solve for. And right here we have a product of two functions, and right here we only have a single fraction. So if we split it up into two, perhaps it will yield the result that we're looking for. And in this case, it absolutely will. So what we can do is we can take one of these signs and move it outside of the fraction. Let's do that. So we have sine y over cos y times sine y. So it's exactly the same as this. We've just manipulated the sign here. Okay, and what's sine y over cos y? Let's bring that up here. That is equal to tan y and sine y. And we've solved the question. Perfect. So, and let's just separate these. All right, so that is the solution to both of those trig identities. Like I said, it's not an easy section, but if with enough practice, you'll be able to kind of understand the common manipulations that are going on, and you should really have no problem with this on the test. Thanks for watching, guys. Stay tuned for more.